Hi everyone, I'm Alok Srivastava, Senior Engineer at Microsoft. Uh, Today I'll take you from the basics to the advance of system design. So I assume every one of us has gone through a system design interview at some of the places because, like or in fact, I say every big company must have taken you through a system design interview. In this channel deep dive, I'll take you through a breadth of system design concepts, and then I'll take you deep dive into some of these concepts so that you can have a clear understanding of how to design a complex system, be it like Amazon or Uber or Flipkart or Facebook. So stay tuned. Thank you. So I think we must all have heard this name. Amazon, it's like world's number one or number two company, but for e-commerce, definitely the number one company. So if I ask you to build a web Amazon kind of an application, how will you proceed doing that? That's what we'll talk here. Going to talk here. All right. So the thing which you are seeing here is my client. So what exactly is a client? So client is something which resides to the end user. So end user is the consumer here. For Amazon, the seller or the buyer, they are the end users. So for us, the client is maybe the browser on which I browse Amazon.com, or it may be the app on which I open Amazon site, Amazon application, or even with TV. Right nowadays, you can buy something from the TV itself. So all these comprises of my client. Now to detail about what exactly is a client server architecture, you can exactly go into the description of this video and see. You can find my video for client service architecture there. So for Amazon, we have clients like web, mobile, or the TV. Now, if you can ask me that how you can develop those clients, there are like various strategies for mobile. For like website, you can build it using you can build a single page application. That's something which is in very much demand these days, and you can use React or Angular or Vue or something like which is coming like every single day. A new framework is coming, and you can use that framework to build the front end, to build the client end, the website of that particular of Amazon. Or you can build an application of something which resides on mobile. And an application, mobile application, it could be also be various types. Like it could be a native application where you build a code separately for iOS, Windows Mobile, or Android Mobile, or it could be a hybrid application where you write code once and it can be ported to the multiple operating systems seamlessly. So you can use a React Native or maybe Ionic for like kind of to build a hybrid application. So that's about the client. But how do client talk to my server? So Amazon is known for its like the billions of transactions that it does every single day, and that's why we prefer to have a microservice architecture for Amazon. That we want multiple services which has to be decoupled and doing a separate piece of work. So I had divided multiple services here. One is the user service, which is we want only for like sign in, sign up, or other user management related stuff. Then I have a product service which take care of what exactly is the products to be seen on my screen. So when I sign in, I must see a catalog of products. So that is being powered by the product service. Then we have an analytics service. So what exactly peculiar about Amazon is that, in fact, that makes it a makes world's number one e-commerce website is that because of the customization that different users get different products when it sign in, and that is because it has a lot of analytics running behind it, and that's why my product service should use the analytics service to power the product to the client. Then we have a payment service that which take care of the all the payment flow when you add something in your cart and then go to the payment page. What will take you from the payment page to create an invoice that should be taken care of by the payment service. Then we have a notification service once you do the payment or once the card is being added. So there are different scenarios when notification get triggered. So maybe like you do the complete the payment flow, and then email has to be triggered to you or the seller that a payment of some product has been done. So that is being taken by the notification service. Like or some other scenarios like you add something to your cart and then you just forget it, and maybe a cron job runs at the back end and sees that whosoever has something added into to a card but hasn't done any action on that, then a notification has to be triggered to those people. So I think that has to be taken care by the notification service. Then we have a search service because Amazon has billions, in fact, much more than that kind of a product items added to it, and we need that search to be extremely blazingly fast. And there must be a separate service to power the search, which using Elastic and other stuff. So there's a search service. Then we have an inventory service because, as I said, Amazon is a platform. So there must be some interface where sellers want to put their products on the site so that it can be bought by the consumer. So that inventory service take care of posting that inventory from the sellers, and my product service might talking to inventory service so that it doesn't display the item which is not there in the inventory, or displays it with the out of stock kind of a label. So this is something which I can like on a high level I can think of. It could be thousands more. So that's the beauty of microservice architecture. You can scale it horizontally. You can add something. You can remove something seamlessly. You can scale up one side. You can like add a chat service to it so that I can seamlessly chat with my seller. So these comprises of my services. Now, do my client need to talk to these services directly? Hell no, because like tomorrow a new service gets added. Are you going to send a new update to your application that okay, your APK has changed, you have to talk to a new service now? No, 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 no. You need to talk to API gateway. So there has to be a something called API gateway. Now, this API gateway hides all the complexities behind. So my client need to talk onto the API gateway, and API gateway knows that okay, this is something related to I to talk it to the user service, or I need to talk to it to a product service. But the client need to talk to API gateway only. Okay, cool. So now what exactly is API gateway? You can find a detail in the description. As I said, it's a deep dive session. You can give a breadth. You can see a breadth of knowledge here, and for deeping diving into something, you need to check the description, and there must be a video there. In case not, you can just comment me in the video. So you have a API gateway. Now, does this API gateway talk to my services directly? Yes, but we need to think about the scaling right now. So since like Amazon has to be highly available, you don't want Amazon to be down, irrespective of the location you are. You are maybe like a US, India, China, America, wherever you want Amazon.com to open very fast. So obviously these services has to be deployed on server, and that server need not to be in a single place. It has to be distributed across the continents, across every place, and we want to make sure that one server doesn't get too much upload. We want to, load has to be distributed evenly. So we must want a load balancer kind of stuff. So here we need a load balancer. Let's call it LB. Now my API gateway talk to the load balancer. Load balancer decides which server it has to route that request to reach to that API, to that service. And because these services are deployed on multiple servers, and that's exactly the microservice thing. We can talk more on that. So yeah, but did I miss something here? Because suppose I log in something and I can re-log in, I get the same data. So why not use something kind of a persistence memory? Why not use something kind of caching? So caching is something we can leverage at any place. Maybe at the client end as well. Like suppose you browse to a site and then you browse it again. You might observe that site has opened blazingly or much more faster than the previous experience because browser caches that thing. So one layer of caching can be here. Let's use a different marker for that. One layer of caching can be on the client end. We can cache stuff at the client end, or we can have a global cache here. Before going to the load balancer, I can just see if it's being present in my global cache. Let's retrieve it from there. Else then go to the load balancer, which go to the server and the microservices. So we can have a caching layer here as well. Now there are different strategies of caching, and uh, again something which we need to deep dive, but just giving a glimpse like Redis or Airspike or Memcache, and there are various eviction policy attached with caching. Like, do we want to remove something which is like least recently used, least frequently used, and it's a topic which like worth deeping dive into it. So yeah, so like while designing, you also have to think like, do we need something to be synchronous or asynchronous? Synchronous is something that where you wait for the response before proceeding further. And asynchronous is something that where you don't wait for the response, you do the stuffs and then you get the data. Or you do the stuffs is been done and then you get a call back that things has been done. Like almost all of the APIs here has to be asynchronous. Like your browser or your application need not to wait or need not to hold its execution till the response is received from the server. You may also have some synchronous stuff at the server to server communication where you want things to get done before moving ahead. Uh, Similarly, you need to also make a call that where you want to have that calculation on the fly or you want to do it beforehand. For example, like for Amazon, uh, everyone has the same home screen except the things or the suggestions that Amazon gives to them. So like one question, like, do we need to calculate that suggestions on the fly or we need to do it beforehand? So I'd recommend do it beforehand, because on the fly calculation would be tremendously computation intensive, and it may you may halt user, or at least one section may be loading before and the whole page may not load because one section is being loaded, is being in load in condition, because your calculation would be higher. So your analytics service should do this thing on the not on the fly, but maybe on a cron stuff, something that you need to browse, you need to look at the user's search experience, or you need to look at the user's buying experience and attach that metadata to the user's ID, so that for when request for a product service comes from a client, you need to know that which client it is, and then give that suggestions by talking to an analytics service which calculates that data on in beforehand, and it gives on the response. So I think, yeah, that's pretty much the high level overview of Amazon, and we can definitely deep dive into various concepts like the client end, what how we can develop a client, how we can create a single page application, or hybrid or native application, what exactly is the difference in that, or what exactly is the type of caching we can have on the client end, what is the API gateway, what exactly is the caching we have at the server end, what's a load balancer, what is the advantage and disadvantage of microservice architecture. So there are like too many questions which can be drilled down from there, and that for that you need to subscribe this channel and tune to it.